All right, part 1, we'll be finishing it up tomorrow. Y equals A, and what do I put here? X minus 3 or X plus 3? To the power of 1 or squared? 1. And all of these we just use 1 or 2. And then I don't use that until the end. And here, what do I put? X minus 1, and here? X minus 4. And why is it quantity squared? Because it's a bounce. And then how do we find the y-intercept? Or how do we find the a using the y-intercept? Plug in 6 for y 6. Because there's a y-intercept of 6. And what do I plug in for all the a's? I'm sorry, for all the x's? 0. And so negative 1, negative 4 squared. All right, so go ahead and figure that out. 6 equals a. What is that? Negative 3 times 16. Does anybody have that simplified? Negative 3 times 16 is negative 48a. And then you do what to both sides? Divide by all right, and does that reduce to negative 8 or negative 1/8? So a equals negative 1/8. Looking at your picture, does it make sense that a is negative? Yep. All right, y or f of x equals negative 1/8 parentheses x plus 3 parentheses x minus 1 and parentheses x minus 4 quantity squared. Don't forget, I did have a few people on the quiz when I walked around yesterday putting the y-intercept at the end. They saw the 6, so they just put a plus 6 at the end. Can you do that when it's in factored form? No, you cannot. You have to work it out the way we did here. All right, questions before I move on to 2? None? All right, sketch. There's a few things we have to do here, even though all it says is sketch. Our high-low end behavior, what's the degree? 2, 3, 4, 5. It's positive or negative? Which means what about our end behavior? Down, up, low, high. All right, what else do I find? X-intercepts and where it cross and bounces. What's this one here? Negative 3 with the multiplicity of 2. This one here, also a multiplicity of 2. What does that mean about the 2 of those? They're bounces. And then the last one is 2, and is that a multiplicity of 1 or 2? 1, don't need to label it. That means a cross or a bounce? Cross. All right, what's the other intercept I cannot forget, otherwise I'd get it wrong on the test? Y-intercept, and how do I find that? X equals 0. Unfortunately, it's not an expanded form. When it's an expanded form is when I could just do taking the last number. Like down here, I could do 0, 0, 0, 0, 0, 18. But this one here is in factored form, so I do have to just show some work. Right here, h of x equals, or h of 0 equals, and I'll let you guys do that now. All right, anybody have it? Negative 36. Anyone else? Agree, disagree? Agree? All right, so we're ready to sketch. Don't forget, when you sketch, you do have to label your intercepts. So let's see, we have negative 3, negative 1, 2, and our y-intercept is negative 36. I'm going to graph it, and then I'll plot that one at the end. Okay, so we said low, high, and which ones are the bounces? These two? Okay, so I'm starting low. I bounce. I know I have to come back up for this one. I bounce. I know I have to go to the y-intercept of what? Negative 36. Then I have this 2 to cross or bounce? Cross. And after I cross it, are there any other intercepts bringing me down? No, that's it. I end on the high piece, and is that correct? Is that what we said earlier, low, high? All right, questions? Definite on the test. And make sure, again, all your intercepts are labeled. We're good? Okay. True or false? A fifth degree polynomial function will have 5x intercepts.
True. False.
Not necessarily, so it could be, it's false. Why not necessarily? It could. Yes, it very, but is it always going to have 5? Okay, some can what?
Be a multiplicity.
Multiplicity of 2 or higher, which means it could bounce or even cross if it's to the third power. What else could happen? Imaginary. So, just because it's the fifth degree, will I have 5x intercepts? No, I'll have 5 roots with multiplicities counted, but not all of them may be intercepts because of the whole bounce and because of imaginary solutions. A polynomial function of degree k will have kx intercepts. False. Is it the same situation? Instead of 5, they put k. So if I said a polynomial function of degree p will have px intercepts. False. Does it matter what letter I put here? No. All right. Make sense? All right. Next one. A polynomial function with a factor of x minus 3. A polynomial function has a factor x minus 3 if and only if f of 3 equals 0. Okay. Tell me why you're saying true.
Because x minus 3 equals 0.
All right. He said, if you didn't hear him, and what did you guys say over there?
I said because x intercept is 3.
Good. Okay. So both of you guys said the same thing. He said here, if x minus 3 equals 0, you get x equals 3. And he said the x-intercept is 3. Do you guys agree? Meaning, if the x-intercept is 3, if it's a root, if it's a solution, what happens when you plug it in? Right? Does that make sense? So if here I had x minus 5, what does that mean about f of 5? 0. If here I had a factor was x plus 7, what would that mean about f of negative 7? Be 0. Does that make sense? If this is a factor, its opposite is a root, meaning it will equal 0. Or as you said, an x-intercept, which means it should equal 0. All right. A polynomial function has a factor x minus a if and only if f of a is 0. True. Is that the same thing that we just did on the last problem? But instead of a number, I put a letter, so still true. If x minus a is a factor, that means a is a solution, which means f of a is 0. Or a is an x-intercept, same thing, which means f of a equals 0. All right. A polynomial with degree 5 must have at least one real root. Why is it false?
Because it will be negatives and imaginary.
No, because the imaginaries have to be multiplicity, they have to have pairs of 2, right?
Okay.
So that would be 4, so it doesn't have.
Does it have to have at least one? Okay. Leonard, can you repeat what, because you said no at first, and then you changed, you're like, wait, and then explain what you thought, what process you went through.
Because the imaginaries have to be pairs of 2.
Okay, so he said imaginaries have to be even in pairs of 2, so 2, 4, 6. So, keep going.
And there can only be 2 pairs to make 4, so it has to be 1 positive and 2.
Good. All right, a polynomial degree 5 must have at least one real root. If we said false, that means all of them have to be imaginary. Can I have 5 imaginary roots? No. 2, 4, 6, and so forth. So at least one has to be imaginary. Is that true with all odd degrees? What about if it was a degree of 4? No, because they could all be imaginary with a degree of 4. Yes?
Is a real root referring to like positive or negative?
Say it again, a real root is talking about non-imaginary solutions. So it could be 5 plus minus root 3. Negative 1/2, as long as there's no imaginary solutions in there. All right, we're good? How many times does a 7th degree polynomial function with roots 5, negative 3, 7, 9, and blah, blah, blah either touch or cross the x-axis? I'm going to have you guys figure that out. Anyone have an answer? How many? 5. Anyone else? 4? 4? Okay, where are we getting the 5 from? Never mind on the 5. Were you getting 5 because this one you counted twice? 1, 2, 3, 4, 5. But this one is a multiplicity of 2. But what does that mean about it? It bounces. It still touches it only once, right? Okay. So how many times does a 7th degree polynomial function with roots blah 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 either touch or cross? So this is a touch, but it's still only once. So how many?
4.
4. What about these right here? Those are the bumps in your graph. So it's not an intercept, it's just a bump in your graph. Make sense? All right, given the polynomial, write as a product of linear factors if 2 and -1 with the multiplicity of 2 are roots. We will not have time to finish this, so I'm going to stop here, and we're going to continue with this when? Tomorrow.